Hi, I'm John Norman. For more than 36 years, I've been fighting fires in big cities, suburbs, and rural areas. I want to thank those who have come before me, and I hope to honor their dedicated service by passing on to you the tools to succeed as a fire officer. My service with the FDNY has had a great influence on what you are about to watch, but I assure you these principles are universal and can be applied wherever you serve. The Fire Officer's Handbook of Tactics DVD series will take you through all the necessary steps to help you become a great fire officer. Not only will it give you the strategy to be a better leader, it will give you the tactics to accomplish your mission. In this presentation, we will discuss size-up operations. Hopefully this term is not new to you, but let's look at a few questions. What is size-up? Who performs it and why? When does it begin? Size-up can be described as an evaluation of the problems and conditions that affect the outcome of a fire. All firefighters have performed a size-up in one way or another, whether they realized it or not. A junior member of an engine company will have different size-up needs and responsibilities as compared to the officer in command. Regardless of rank or duty, both need to perform a size-up, and the information gained will affect the operational status of each firefighter at the scene. When you think about it, a firefighter's size-up can determine whether a firefighter lives or dies. This is not something we should wait to do until the chief arrives. A proper size-up must be performed right away when arriving on any fire scene. In fact, a proper size-up begins from the moment the alarm is received and continues until the emergency is under control. It is basically an information gathering process. That being said, the size-up should include, but not be limited to, the information gathered during pre-planning activities. So remember, it starts in pre-planning and continues throughout the emergency. Let's look at a typical scenario. At 2:30 a.m., your firefighters received the following dispatch message. Attention engines 1 and 3, ladder 2, chief 1 and rescue 1. Respond to a report of a store fire across from number 1510 Main Street. The first thing you should notice is the time of day. If you were sound asleep, most likely the call is a delayed alarm, so the fire has had some time to develop. The next consideration is the location of the fire. A good fire officer knows their area. They know where the major intersections are and how the buildings are numbered. This will help you position your crews on the appropriate cross street or near the nearest hydrant. Also, don't assume that just because it's a store at 2:30 a.m. that there's not a life hazard involved. There are many mixed commercial and residential buildings where a fire that starts in a store on a street level can trap sleeping occupants above the fire. Another life hazard that has to be considered is the life of the firefighter. There is no excuse for endangering the lives of your members by sending them into a vacant store that's been fully involved for some time. In fact, at this point, you don't even know how long the fire has been burning, or if you've passed the 20-minute time frame. Concern about collapse is very real here, and should always be considered when sizing up the situation. Other information that can help you with the size-up can be found in the dispatch call. A good fire officer needs to be familiar with what is standard and what is out of the ordinary for any given call. Why were engines 1 and 3 called and not engine 2? Was rescue 1 called because there were trapped occupants? And how about crew levels? Do you have enough staffing? Is this 2:30 a.m. in March, or is it 2:30 a.m. on New Year's Eve, when a volunteer department might be short-handed? All these things should be registering in the head of each officer and firefighter. Size-up must start right away, even as the members are getting dressed. So what exactly is entailed in a proper size-up? There is an acronym that is tried and true that will help you remember the main factors that go into a proper size-up of a structural fire. The acronym is COLWA's Wealth. C is for construction. O is for occupancy. A is for apparatus and manpower. L is for life hazard. W is for water supply. A is for auxiliary appliances. S is for street conditions. W is for weather. E is for exposures. A is for area and height. L is for location and extent of the fire. T is for time. H is for hazmat. So there they are, the 13 main factors that will go into any size-up operation. Let's look at them more closely, this time in the order of our priorities. Let's start with the life hazard. Remember, as a firefighter, protecting life is always your first priority. Life hazard comes in two forms, them and us, or civilians and firefighters. You do no good for trapped occupants if you become a casualty, and the rescue of a trapped firefighter is far more difficult than that of a civilian. The life hazard is so important that it must be the deciding factor in determining tactics and procedures. Time of day and location and extent of the fire create the life hazard. The best way to mitigate a life hazard is to prevent it in the first place, through improved exit facilities or installing a sprinkler system. Finally, we the firefighters become a life hazard whenever we arrive on a scene. A careful evaluation of the civilian life hazard should be made before committing the life of a firefighter to attacking any fire. This leads us to the next factor in size up when it comes to life hazard, and that is the evaluation of the building's occupancy. When responding to a fire, we often ask, what kind of building is it? Is it a factory? Is it a school? What we are asking is, what is the building used for? Who or what is inside it? The type of construction is also very important, and we will discuss that later. For right now, we need to know who is inside the building we are responding to. The time of day is also important, because a school at 10 p.m. on a weekend poses a much lower life hazard than at 10 a.m. on a school day. Some buildings have a high life hazard 24 hours a day, such as a hospital or nursing home. It is only in response to high civilian occupancy that we should take an aggressive approach. I cannot stress enough the importance of protecting the life of a firefighter when engaging fires in unoccupied buildings, where the threat to civilians is minimal. Every year, we send firefighters into harm's way. Sometimes there's a justifiable reason for this risk, to save civilian lives. What is not justifiable is sending firefighters into vacant buildings, where the risk to civilian lives is non-existent. In fact, the ridiculous part of this is that we are killing firefighters at 4 times the rate in vacant buildings than in occupied residential buildings. This trend must be stopped. Vacant buildings have no life hazard until we arrive. When you arrive on a well-involved vacant building, grab your crews and tell them, look, there's no civilian life hazard in there. Be careful. I want you all coming home with me in one piece. The occupancy can tip you off to the type of construction involved. Churches, car dealerships, and bowling alleys are all found in large truss roof spaces that have a high potential for collapse as well as a very high fire load. Retail spaces are usually smaller enclosed spaces that make a hose line attack more difficult. Another important part of occupancy in relation to size up is the potential presence of hazardous materials. If available, pre-planning books, or better yet, a CADS, a computer-aided dispatch system, helps to remind us when we're about to encounter a dangerous fire scene. Most firefighters know that when responding to a call at a chemical supply warehouse, they're going to encounter hazmats. But it's in occupancies that might be housing material that's out of the ordinary where the CAD system comes in handy. Whenever there's a potential for hazmats, it's a good idea for the dispatcher to broadcast a CADS message on the radio as the units are responding, and also send a teletype version as well. That way, all are reminded of the dangerous situation, while the teletype version puts a hard copy in the hands of the leaders. The more information we know, and the sooner we know it, the better the size-up can be performed. And ultimately, that leads to an increase in our ability to protect the lives of both civilians and our own. Now let's look at how time is a major factor in any size-up operation. As we have discussed before, the time of day that the incident occurs is very important. In regard to life hazard, a fire in any residential occupancy at 2 a.m. will greatly increase the likelihood that civilians are in danger. The time of year should also be considered, because this can have an impact on your personnel levels as well. A call that comes in on December 24th at midnight might find the incident commander with far fewer members to help fight a fire. Also imagine the seriousness if that same call was for a church. Usually a midnight church fire is an unoccupied structure, but the time of year, Christmas Eve, makes a huge difference. One night I responded as the chief of my volunteer department. It was a working fire on the top floor of a large, vacant, wood-frame boarding house. Usually 2 well-placed hose lines and a backup master stream from our tower ladder would make quick work of the fire. I went a step further, though, because of the time of day and the time of year. This incident happened an hour after our department's Christmas party, and most of the bars in town were still open. I went ahead and ordered additional mutual aid just in case it was needed. If you're the one standing in the street wearing a white hat, make sure you have a plan. Remember, hope is not an effective strategy. Oh, don't forget that the time of year has a bearing on fire load as well. From October through the New Year, stores are full of merchandise. And those beautiful yet highly flammable holiday decorations makes for a dangerous recipe. Now I want to talk about the most important factor in the time equation in regard to your size up. The elapsed time since flashover is the single most important aspect concerning time. As the leader on a fire ground, you have to be able to assess how long the fire has been burning. This determination will help you to judge whether you can conduct an interior attack or you have to stand back and take defensive positions. This is more of an art than an exact science. There are many factors that go into determining how long a fire has been burning. As a fire officer, you're going to need to rely on experience and thorough reporting by all members on the fire ground. Variables such as the type of construction, the fire loading, the length of burn before the alarm was transmitted, and alterations to the original structural design all play a role in determining whether we can conduct an interior attack or not. Let's remember the Twin Towers of the World Trade Center. They had a fire resistance rating of 3 hours for key structural elements, like columns. 3 hours would have been a blessing because in reality they had much less time. One tower stood for less than an hour after the impact and ignition, while the other stood for an hour and 45 minutes. The impact and fire loading played significant roles in how long they stood before collapsing. The incident commander had no reliable way to determine collapse time because of the nature of the impacts and the fire load. In fact, we need to keep in mind that the increased use of plastics in our modern society places a tremendous increase in the fire load in the structure. This has an effect on the standard time temperature curve that was used to create the fire resistance ratings. A good fire officer must be ready to adapt. In my many years as a fire officer, I must say that structural collapse is the most difficult of all fireground dangers to predict. One rule of thumb that's been effective in the past is the 20-minute rule. This is only a guideline, and the type of construction has a huge impact on whether it can be used at all. The most common structures that we operate in, residential housing as well as smaller commercial buildings, are basically built the same way. They use either a Class 5 wood frame or ordinary Class 3 brick and wood joist construction. These are highly predictable structures and tend to behave similarly under fire conditions. And for most residential buildings, the furnishings and fire load tend to be the same, which gives us a predictable burn behavior. Now, the 20-minute rule only applies to these two types of construction. If the fire has not been brought under control within 20 minutes, you should consider taking a more defensive posture. Again, this is a guideline and must be applied carefully, weighing all the factors involved. It's important to remember that when we're discussing the amount of time the fire has been attacking a structure, we're talking about how long it's been since flashover. That's because this is when the fire begins to attack the structure itself. If we can determine that, we can know with some confidence how long the structure will stand and how long we can safely operate inside the structure. Assuming you were not present for the actual flashover, how do you know how long a structure has been at the post-flashover stage? Well, we can't know for sure, but we can estimate it. Here's how. One method is to observe the fire that is venting through window and door openings. A fire that is not vented from any openings has not been at the flashover stage for very long. A fire that is vented from only 1 or 2 windows is most likely confined to one room and has only been at the flashover stage for 1 to 5 minutes. So if you observe that the windows on either side of a fire room have not yet vented, that's a good indication that you have time to get in and attack it. The more windows that are showing fire, the longer the fire has been burning. If you notice that fire is venting on 2 floors, that's a sign of prolonged fire. Most likely the fire has been at flashover for 10 minutes or more, or an accelerant may have been used. This kind of dangerous situation should prompt you to attack with caution. Look for signs of prolonged burning, like fire coming through a wall. This usually indicates the fire has been burning for a considerable amount of time, and collapse may be imminent. Stay alert to potential accelerants, especially liquid accelerants that can penetrate floors and stairs. Many firefighters have been injured during arson fires when the stairs collapsed beneath them. Also be aware of the history of the building, like previous fires or extensive renovation. This will usually indicate a weaker structure that can lead to quicker collapse. Given all these factors, if there is no indication of prolonged fire, a standard interior attack can be launched. If it does not succeed in a timely manner, you, the incident commander, must decide why and take the proper course of action. If the first crew's expended their 30-minute air cylinders and their officer reports that the main body of fire has been knocked down, you have more choices to make. Is it safe to send the crews back in, or do you pull back and attack from the outside? If you decide there's no danger and the fire is being extinguished, then press on with the interior attack. If, however, you feel that there is still a large portion of fire left to suppress, you have to order your crews out. This is where you must learn to be a leader. You must be able to make command decisions when the safety of your members is on the line. As the incident commander, you must evaluate all the factors and take reports from all sectors, then make the call. Only you, the incident commander, can make the final decision to attack or withdraw. You are the only one with the big picture. I recall operating with my engine company, taking on a lot of fire on the first floor of a 4-story building when we were suddenly ordered out by the chief. We were making a lot of headway and reported back to the incident commander, "Just a few more minutes, chief, we got it." Well, the chief sounded really, shall we say, agitated as he repeated his order to get out of the building now. Sure enough, imagine our surprise when we exited the building to see the top 3 floors fully involved and blazing away. Remember, it's the big picture that counts. When you're ordered to retreat, just do it. Your life will most likely depend on it. At At the height of a serious fire, it's easy to lose track of time. Many experienced chiefs have used the air bottle rule or the 20-minute rule as a way to gauge when the structure may be in danger of collapse. Usually, a 30-minute air cylinder will only last about 15 to 20 minutes when the firefighter is working hard. After this initial 20-minute attack, if the fire has not been knocked down, it's probably a good time to reevaluate how aggressive the attack should be. Now, this 20-minute rule is not bad, but remember that it only works for the wood joist construction of Class 3 and Class 5 buildings. Also be aware that many departments are switching to larger capacity air cylinders. This can jeopardize firefighter safety if the incident commander is relying on the length of the air cylinder to determine how long to continue the attack. In fact, in New York City, we use a system to help keep the incident commander aware of the elapsed time. The incident commander must transmit periodic reports on the incident, starting at 5 minutes after arriving on the scene. Then, after an additional 10 minutes, they give a progress report. Now, the 20-minute rule does not apply to all scenarios. It does not apply to Class 1 or Class 4 building types. These types of construction can withstand much more fire exposure and allow the fire crews to work much longer without the risk of collapse. Let's look at another exception to the 20-minute rule, though, and this time it is not that it is too short, but rather that it is too long. When fighting Class 2 buildings, metal deck roofs, or buildings made of lightweight wood framing or metal C-joists, you need to know that they have all been proven to collapse with as little as 5 minutes of fire exposure. You should be aware of these types of buildings in your area and make standard policies in your department that unless there is a civilian life hazard, once flashover has occurred, these buildings should be fought using defensive tactics. This information should also be included in your pre-planning and CADS messages as well. Unprotected steel trusses can be expected to fail in as little as 5 minutes in a serious fire. Even large bowstring trusses are vulnerable, and I've seen them collapse in as little as 8 minutes after flashover. Remember, we're talking about time right now, the time that the fire has been burning since flashover. You have to be able to judge how long a structure has been exposed to flashover. That is also why you must know the different types of construction and how the fire affects them. To start, let's examine the 5 major implications that construction will have on your size-up. The first factor has to do with compartmentation of the building. The number and size of compartments found in a building and the fire resistance rating of the dividing walls and floors will either increase or delay the spread of fire. The second implication has to do with how the building itself contributes to the fire load. Older buildings made of wood construction add to the fire load, while newer metal construction adds very little to the load. Of course, be careful of metal deck roofs. These are built with a layer of tar on top of them, and when the underside is exposed to fire, the asphalt heats up and starts to pour flaming tar down into the building. This is another reason why a fire officer needs to determine the type of building he's encountered during size-up. The third factor related to a building's construction has to do with the number of voids found in a structure. These voids are usually hidden and act as highways for fire travel. Cocklofts, pipe chases, and channel rail voids all contribute to the spread of fire. In fact, voids are responsible for the destruction by fire of more buildings than any other construction-related factor. The fourth concern, and probably the most important to the safety of firefighters, is the building's ability to resist collapse during a fire. Fire works with gravity to loosen the joints to keep it standing. A poured concrete building will have a better resistance to collapse than a normal 2x4 wood frame structure will. Finally, the fifth factor that must be understood is that all materials have a point of overload. A building may be on the brink of its overload point and still stand. Cross that point and collapse is imminent. Be aware that the weight of the water and the firefighters themselves may be the straw that breaks the camel's back. Let's explore the major classes of construction. The National Fire Protection Association lists the 5 classes as follows. Class 1, fire resistive. Class 2, non-combustible. Class 3, ordinary construction. Class 4, heavy timber. And Class 5, wood frame. The Class 1 structure is made of walls, partitions, columns, floors, and roofs that are all non-combustible. Some codes call these fireproof buildings, but let's think about that. Even though your oven at home does not burn, the contents inside get very hot. That's a good way to look at these structures. They're huge ovens. The structures themselves don't add to the fire load, but the contents sure do. There have been some exceptions to this recently, though. The events of 9/11, along with the fire at One Meridian Plaza in Philadelphia, have shown that these structures are not completely impervious to fire. To say that these buildings are fireproof is not exactly accurate. In fact, since World War II, we've seen lighter weight materials used more often. That makes modern Class 1 structures less resistant to the effect of fire. The next class of construction is the Class 2, or non-combustible structures. The word non-combustible is very misleading. In these structures, the walls, columns, floors, and roof are non-combustible, but are less resistive to fire than Class 1 buildings. They're usually built with metal decking and unprotected steel joists. That leaves these buildings very vulnerable to collapse when subjected to fire. The next group of structures is the Class 3, or ordinary construction buildings. These are usually made of masonry or other non-combustible walls with a 2-hour fire resistance rating. The floors, roofs, and interior partitions are usually made of wood, however. These types of buildings are susceptible to burn through and eventual collapse. Most brick buildings are built this way. The next class of structure is the Class 4, or heavy timber construction. Usually the exterior walls of these buildings are made of masonry or some other non-combustible material that gives a 2-hour fire resistance rating. The main difference with this class of construction is the use of heavy timber in the interior of the structure, usually a minimum of 8 by 8 for columns. These structures themselves add a tremendous fire load, but because the timber used is so massive, it usually is not easily ignited. Also, once ignited, the heavy timber construction maintains its integrity fairly well, even better than unprotected steel. These buildings are often built without a lot of void spaces, which makes fighting fires in them less complex than in some other buildings. The last group is Class 5, which are buildings made from wood or some other combustible material. That is how most homes in North America are built. Collapse is not usually an initial concern in these structures. So let's review a little here. Remember the Size Up acronym, Coal was Wealth. So far we have talked about life hazard, occupancy, time, and construction types. Now let's look at the height and area of a building when sizing up a fire scene. The height and area of a building are important because they represent the total potential fire area. Sometimes it's not obvious how high a structure is or its total area. Think about buildings that are built on a grade or a hillside. From one street level, it looks like a 6-story building, when in fact it could be 8 or more stories if seen from the lower level. Remember, don't assume you know. A proper size-up helps you make the right decisions. Knowing the true height of a building will tip you off to certain construction features. A 3-story building most likely will not have a standpipe, whereas larger, high-rise buildings will most likely be built of Class 1 construction and have a standpipe system. The frontage of a building is important because it can give you a good indication of the size and area the building encompasses. Don't be fooled though. A view from the roof is usually the best way to confirm the size and dimensions of a building. Sometimes a building that looks like a 25-foot wide front could go back and widen out to over 100 feet across. This means that what looks like a relatively small building could contain a very large fire. Also, look for extensions and possible openings where buildings seem to join. These areas will give a path for the fire to travel and can potentially involve more than one building very quickly. Again, get your size up done quickly and thoroughly so that a single building fire does not become a multi-structure fire because of a poor size up. The next step in the size up is to determine the location and extent of the fire. Unlike other size-up factors, finding the location of the fire has to be done by physically surveying the scene after arrival. The original reporting party can lead you in the general direction, but don't rely totally on their report. Many times the smoke trail is misleading, especially if there's a central air conditioning unit in the structure. In a serious fire, the actual location of the fire will have a big impact on the tactics used to fight it. Generally, if the fire is lower in the structure, there's a greater chance for the fire to spread upward into more floors and trap more occupants. Also, be careful of fires that start near the roof of a building, as there are usually voids between the top floor ceiling and the roof. These voids create increased danger for firefighters and the occupant. Another problematic location for fire is when they start below grade. Whether it's in a basement, a subway, or below deck on a ship, fires below grade are always more complex than those above. That's because of the lack of horizontal ventilation, making stairways act as chimneys for the escaping heat and smoke. This in turn makes it difficult for access and getting crews in and out of the fire scene. Yet another difficult location for a fire is anywhere that's a problem ventilating. This usually happens when a fire is beyond the reach of ladders or where there are no windows in the building. Ventilating this type structure becomes much more difficult, and therefore tactics become very similar to fighting a below-grade fire. Many times, determining the extent of a fire is very difficult. Smoldering fires may look like working fires due to the volume of smoke they produce. Understanding how to evaluate the different types of smoke can assist you in knowing the extent of the fire as you do your size up. This again is not an exact science, but will give you clues that lead you in the right direction as you determine the extent of the fire. When evaluating smoke, you should look for the location of the smoke, the color, and the movement of the smoke. You must learn to trace the smoke back to its source. Knowing the normal smoke diffusion pattern, up and out, You can usually trace the smoke back to the fire. Be aware that objects moving in a shaft, like an elevator or a central air conditioning system, can push smoke to other parts of the structure that are not involved. This is rare, but it does happen, and you need to be aware of it. Normally, any floor with smoke on it will be at or above the actual fire. Never bypass a floor with smoke on it without looking for the source, even if the report of the fire is on a different floor. In fact, if you find all the floors pushing heavy smoke but find no signs of actual fire, look in the cellar. This is a classic indication that the fire is below grade, especially if the chimney is throwing out a lot of heavy, dirty smoke. The color of the smoke can many times give you an idea of what's burning. Black smoke is an indication of the presence of petroleum products. Light to moderate smoke in a basement often means that the oil burner is malfunctioning, and that means you'll need to bring a Class B extinguisher. When evaluating a residential fire, we can no longer assume that if we see black smoke that there was some sort of accelerant used. Because of the proliferation of plastics used in our modern society, black smoke is becoming more and more common. Common Class A materials produce a gray to light brown smoke when burned. When there are reduced amounts of oxygen present, this changes to large amounts of dark gray or yellow-gray smoke. Pay attention to this type of smoke, especially if you see it being drawn back into the building, for this is a good indication of a potential backdraft. Not only will the color of the smoke give you clues to the extent of the fire, but the direction or movement of the smoke can as well. Light wispy smoke usually indicates that the fire is in the early stages. Heavy, rolling clouds violently twisting skyward indicate extremely hot smoke from a well-involved fire. Fire usually ignites through this rolling smoke and presents a great danger to firefighters. As the incident commander, you need to be alert to these conditions. You don't want your crews trapped inside a structure during a flashover. Smoke that hovers near the ground indicates a partially or fully extinguished fire. The smoke hovers near the ground because it's lost most of its heat. This is common at fires in sprinkler buildings. Be careful here. Partially extinguished fires emit large amounts of carbon monoxide, so make sure the crew members use their SCBA until the area is monitored to be safe. So stay vigilant. Locating and understanding the extent of the fire is sometimes difficult, but it's very important. Learn to investigate thoroughly and know what the smoke is telling you. Next, let's look at a very important part of your size-up. In fact, this should be your next priority after the life hazard. The protection of exposures is the next step in your evaluation and the natural extension of your fire locating operations. The examination of exposures should include all 6 sides, front and rear, left and right, top and bottom. On large structures, it's impractical to expect the IC to personally inspect all 6 sides. All members must be able to identify the areas in which they're operating and clearly communicate the conditions they encounter to the incident commander. One common method of identifying the areas in and around the fire building is the numbering system. Beginning at the front and working around the building clockwise, each side is numbered. Exposure 1 is the front of the building. Exposure 2 is the building to the left. Exposure 3 is the building to the rear, and exposure 4 is the building to the right. This system is superior to simply using letters for this purpose when operating in densely populated areas. This system can then be applied to attached buildings, such as townhouses or garden apartments, by adding a letter to the numbering system. So exposure 2A is the second building to the left. Exposure 4A is the second building to the right, and so forth. If you see that there's a threat to an exposure, you must take action to prevent extension. The obvious course of action is to put the fire out. That's not always possible, however. There may be gas that is ignited that needs to burn out on its own, or the fire is just too large to extinguish rapidly. In some cases, you may be able to move the fire or the exposure if possible. I recall one very busy summer evening when I was a firefighter in Ladder 103, and we pulled up first at a 30-yard dumpster fire. There was a dangerous exposure to a cardboard box factory. In fact, when we arrived, the dumpster was fully involved and the windows of the factory were starting to crack. To complicate matters, the nearest engine company was coming from a considerable distance away. Something had to be done. The fire was about to extend into the factory, igniting piles of cardboard boxes. Our quick-thinking chauffeur pulled the tow chain out of the apparatus and tethered the dumpster to the rig's tow eyes. He then drove down the street to a vacant lot where the nearest hydrant was located. It sure was something to see that blazing dumpster barreling down the street behind the rig. That's a great lesson on how to reduce the threat to exposures. When you can't remove the threat completely, take decisive action to protect any exposures that might extend the fire. So far, we've discussed many factors that will help you determine tactics to use as the incident commander. Don't forget, we're still talking about the Cole was Wealth acronym for size-up. The final group of size-up factors can be vital in determining how aggressive or defensive you will be at the fire scene. These factors deal mainly with your available resources to combat the fire. You first need to plan your attack based on what apparatus you have, along with the available staffing. You need to know how many engines are responding. Do you need aerial units? Do you have full crews or are you understaffed? Who's coming? Is this your A team or something less than your best? Regardless of reasons, there are always some crews that perform better than others. The fire doesn't know that, of course, but the officer in command should. Knowing the answer to these questions will help better orchestrate a successful outcome. Closely linked to the apparatus and staffing is the water supply. The engine companies usually cover this function, but there's more to water supply than making sure you have enough pumpers on hand. It's good to look at water supply as a system. It must be a system that delivers enough volume to suppress the BTUs being produced by the fire. A typical water supply system consists of a hydrant that supplies a feeder line. The feeder line is connected to a pumper. The pumper then supplies water to several hand lines to attack the fire. Evaluating your water supply actually starts in a pre-planning stage. Get to know your area and find those locations that have reduced water pressure, where in case of an incident, you'll need to move water from somewhere else. If your area has uniformly good water supplies, the pre-plan can be as simple as making sure you know where all the hydrants are. Next, we need to look at the actual amount of water that you need for a given fire. There are several methods that can be used to determine this. In simple terms, the fire flow will depend on the amount of fire load and the area involved. The actual formula is based on a scientific principle involving the amount of heat that 1 pound of fuel releases when it burns versus the heat dissipation ability of water as it's vaporized. The typical residential room has a fire loading of about 5 pounds of fuel per square foot. Libraries have much more, something like 25 to 30 pounds of fuel per square foot. Each pound of cellulose-based combustible gives off 7,000 to 10,000 BTUs when consumed by fire. Plastics give off much more, in some cases double what wood and paper produce. Each gallon of water can absorb 9,275 BTUs when heated from 70 degrees and turned into steam. So in theory, 1 gallon of water will provide enough heat absorption to extinguish 5 pounds of fuel. Thus, when calculating fire flow, we use how many gallons per minute will be needed to extinguish the fire. Now, trying to calculate specific fire flow needs using these formulas out on the fire ground is just not practical. Thanks to the good work of the NFPA, Factory Mutual, Iowa State University, and others, we have a general rule we can apply to most fire scenes. They've determined that a flow of 10 gallons per minute is needed to cover 100 square feet of light fire load. For heavier fire loads, it should be 20 to 30 gallons per minute, and for very heavy fire loads, a flow of 30 to 50 gallons per minute will be needed for every 100 square feet of fire. So using this formula, we can determine the theoretical fire flow needs for just about any given fire. This, in turn, will help you determine your apparatus and staffing needs. Let's look at some examples. An engine company responds to a fire in a single-story residential building that measures 20 by 30 feet. A flow of 60 gallons per minute should be sufficient for knockdown at this fire. What if it was a store that measured 20 by 75 feet? A flow of 300 to 450 gallons per minute would be needed for knockdown here. Let's take it one step further and look at a tire warehouse that measures 100 by 150 feet. This would require a massive fire flow of at least 7,500 gallons per minute. How these flows are applied varies widely, from a 1.5 inch hand line for the one-story home to various master streams and large hand lines for the warehouse. The flow rate formula works great for pre-planning, but in actuality, these flows are generally not applied. Today's modern nozzles have a much higher flow rate. An 1.5 inch nozzle has a flow of 125 gallons a minute, while an 1 3/4 inch nozzle can flow 150 to 200 gallons per minute. The nozzle team will take advantage of this increased flow and lead an attack that's quicker and more efficient than at the 60 GPM rate. The faster knockdown aids in the rescue of any potential victims and also reduces damage to the structure. As for the second example, a fully involved store fire usually means the front windows are blown out. With that much fire showing, the knowledgeable fire officer should opt for a quick knockdown, using a higher fire flow than the formula dictates. Many times, a deck gun or other fast-acting master stream is used here. In the case of the tire warehouse, a 7,500 GPM fire flow is rarely ever applied. That's because it's very rare for such occupancies not to have some sort of automatic fire protection system in place. That means that most likely the entire building will not be completely involved when the firefighters arrive. A quick attack of 1,000 gallons a minute or more ought to take care of what fire the sprinklers have not extinguished. Another reason why the 7,500 GPM fire flow would not be used is simply because of the sheer amount of water needed and the time it takes to establish that flow. It's usually impractical and sometimes impossible to deliver that volume of water at a given fire scene, because many municipalities know that building codes exist to make sure that high-hazard occupancies like a tire warehouse must have sprinklers. Some years ago, I was asked to give a deposition in a civil suit. The owners of a paint factory were suing a Midwestern city after their building was destroyed by fire. The owners claimed that the city failed to provide sufficient water to successfully fight the fire. I testified that with the size of the factory, a 4,500 gallon per minute fire flow would be needed. I said that based on the amount of fire already present when the fire department arrived, there was no hope of saving the structure. The amount of time needed to secure a fire flow of 4,500 gallons per minute precluded any hope of saving the building. We won the case. In fact, the owners had been ordered by the city to install sprinklers, but had failed to do so. They then had the nerve to sue the city over the lack of water, when they could have saved their own building if they had just installed the sprinklers. That brings us to another item that deserves attention during size-up: the presence and serviceability of auxiliary appliances. In addition to sprinklers, other auxiliary appliances exist, like standpipe systems, foam, halon, carbon dioxide, and dry chemical systems that cover a wide range of occupancy needs. After addressing any life hazard that takes priority, first arriving units must evaluate whether an auxiliary appliance is present and what the operational status is. If there is a system present, does it work? Is it working now? If not, can it be operated manually or bypassed using a fire department connection? A non-working auxiliary appliance is often a justification for calling additional assistance. Without the auxiliary system, the firefighters will face an uphill battle. Now let's examine the last three factors in a size-up. Weather conditions should always be accounted for as you arrive on a fire scene. Hot and humid weather adds to the fatigue factor of the firefighters. Under these conditions, early relief of the attack team is essential to their well-being. In fact, any extreme of weather, either hot or cold, should prompt a call for additional assistance. Cold weather is particularly dangerous when ice forms on the ground, making just walking around the fire scene problematic. Cold also leads to frozen hydrants and apparatus malfunctions. In fact, I recall a 10-alarm fire in Brooklyn where the frozen basket piping on a telescoping platform allowed a fire to extend to an 8-story factory. Also, watch for high wind advisories as well, as this can feed the fire and cause it to spread very rapidly. The next factor in your size-up should be to observe street conditions. Double-parked cars, construction trenches, and even heavily snow-packed streets all hamper efforts to fight the fire. When you encounter obstacles like these, usually the engine company has to park farther away than normal. This means the hose line stretch will be much longer. As you size up street conditions, be aware of these needs and plan accordingly. The last factor in your size-up should be the evaluation of any potential hazardous materials. Hazmats pose many dangers, as health hazards, reactive agents, and potential accelerants. Hazmats can be anticipated and should be included in the CAD system or pre-planning book. Some hazmats are of less consequence than others, like a routine flammable liquids fire, but others involving poisons and explosives can halt the fire operations entirely. As the incident commander, you need to know immediately if there are hazmats present, and if so, what specific hazards they pose for operations. Today we discussed the proper way to conduct the size-up. We talked about the acronym COLE was Wealth. C is for construction. O is for occupancy. A is for apparatus and manpower. L is for life hazard. W is for water supply. A is for auxiliary appliances. S is for street conditions. W is for weather. E is for exposures. A is for area and height. L is for location and extent of the fire. T is for time. H is for hazmat. At a given incident, any of these factors might be just a minor detail, or they could be the reason for calling additional resources. As the incident commander, it's imperative that you are armed with all the information available to make proper command decisions. Thanks for watching today. This Fire Officer's Handbook of Tactics DVD series is here to help you make better decisions each time you're the incident commander. Stay safe. I'm John Norman.